There's nothing really mysterious about quality. It takes dedicated craftsmanship and attention to detail. Like this clock, it could have been mediocre. It could have been just a cheap, inaccurate clock. Instead, it's a precision timepiece. Of course, in CRT manufacturing, we don't make clocks. But the philosophy of quality that went into the making of this clock is the philosophy we want you to remember when you think of Tektronix CRTs. After all, quality is more than a product. It's a state of mind. We'd like to welcome you to the cathode ray tube manufacturing area. We're very proud of our product and of the people who help in its production. Before we start our tour of the production area, let's talk about cathode ray tubes and oscilloscopes. The cathode ray tube, CRT for short, is the heart of an oscilloscope. In general, oscilloscopes are used to view electrical signals such as those found in electronic equipment, including computers and telecommunication systems. The oscilloscope, CRT, is similar in structure to a television picture tube. They both receive an electrical signal that is transformed into a picture on the screen.
The Four Corners area down in Arizona,
the television picture tube can show the condition of the weather. The oscilloscope can show the condition of an electrical circuit. It converts an electrical impulse into a pattern of light that is meaningful to the user. This pattern of light is called a trace. The main component of the oscilloscope is the CRT, which has three basic parts: the electron gun, the funnel, and the faceplate with its phosphor screen. We make many different kinds of CRTs, each for a special use. You'll see the differences as we go on our tour. At the far end of the electron gun is the cathode grid assembly. The cathode is like a pan of water on a stove. Electricity heats up the cathode and causes it to give off electrons, just like a pan of water heated to boiling gives off steam. The electron gun focuses and accelerates the electrons given off by the hot cathode into a narrow beam. This beam strikes the phosphor screen that glows brightly at the point where the electrons strike. Electrons in the beam have a negative electrical charge. As the beam passes through the gun, positive charges are applied to metal plates called deflection plates. One pair deflects the beam vertically and one pair deflects the beam horizontally. The beam will move toward the plate with the most positive charge. When the charges on the opposing plates are changed, the electron beam is moved across the screen. That's how the pattern or trace is created. Electrons are very small particles, so small that air molecules can knock them off course. This is where the funnel comes in. If we projected the electron beam onto the screen through the air, the beam would be so diffused or spread out, the image would be meaningless. The beam needs a special environment that has very few air molecules. So we put a protective shell around it. This shell is called a tube envelope. The tube envelope consists of the faceplate, the funnel, and glass tubing around the gun. Okay, the beam is in a protected environment, but the air still makes things difficult. We need to get rid of the air molecules. A vacuum pump is used to suck all the air out of the envelope, and then the end of the CRT is permanently sealed. Quality is the prime concern in CRT. It takes so many parts to make a tube, and there are so many steps in the process, that every step must be done exactly right. Each operator is responsible for his or her own work. One way to help operators produce quality parts is to be sure that all the raw material they work with is up to our standards. The quality audit inspectors measure, test, and visually inspect a sampling of material coming into CRT. This includes glass, and reels of metal. This machine is called a comparator. Material or parts are compared with the specifications, and if acceptable, they're sent to the manufacturing areas. Other audits are done throughout the process to ensure our quality standards. After the glass has gone through the audit, it's sent to the glass fabrication area. Here the glass is cut and formed into different sizes and shapes, such as the glass tube that surrounds the gun, the stem, and the beaded pins used to connect internal parts to the outside of the tube. Let's follow the process of making a stem. First, the glass tubing is cut to length. And fire polished to smooth the edges. This complex machine quickly accomplishes several tasks. First, the connector pins are put into place. Then the small glass tube and larger glass ring are set in the mold. The larger glass ring is melted around the pins to form the stem. The pins must be heated in a hydrogen atmosphere to bake off any oxidation that might have formed. Then the pins are cut and bent according to an exact pattern. All the glass is annealed before it leaves glass fab. This relieves strain in the glass, which could cause the glass to crack or break. We'll see products of glass fab being used later in the process. Throughout CRT manufacturing processes, attention to quality is our #1 concern. The outer portion of the CRT, called the bulb, is assembled in the CRT processing area. Here in faceplate prep, the raw glass is unpacked and cleaned. And the glass must be handled with great care. The smallest chip or scratch can ruin a plate. A precise pattern called a graticule is silk screened onto the plate. The paste for the pattern is a powdered glass-like material. When it is baked, the pattern is permanently bonded to the glass faceplate. During this step, the environment must be closely controlled because contamination of the faceplate will cause a bad pattern. After the pattern is printed on the faceplate, it goes to ceramic assembly where it's attached to the front of a ceramic funnel. The funnels are made right here at Tech and coated on the inside with a conductive layer of gold. The material, called frit, is used to bond the glass faceplate and neck ring to the funnel. It's a combination of powdered glass and oxides. The assembly is baked at a high temperature to permanently seal the pieces together. In this area, called target deposition, a layer of phosphor is deposited on the inside of the faceplate. You may recall, in operating CRTs, the electron beam strikes the phosphor particles, causing them to glow. When target deposition is finished, the faceplate takes on a new look. After the phosphor is deposited on the glass, its quality is checked with a machine that generates electrons. It's called a glow discharger. The electrons cause the entire phosphor layer to glow. Following this quality check, the phosphor is sprayed with lacquer. Then a layer of aluminum is added. The lacquer is baked out, leaving the smooth layer of aluminum resting on the phosphor. The aluminum then acts like a mirror to brighten the trace. The faceplate is quality checked again in the darkened room. The result is a finished bulb with a ready-to-use faceplate, now called a target. The next step in the manufacture of a CRT involves the electron gun. After the raw metal reels have been quality audited, they come to this area, known as punch press. The reels of metal are fed through machines and formed into various shapes. There are large mechanical presses that form the metal into specific shapes. And machines that cut and bend the narrower metal. Here are some of the parts from punch press. Each of them has an important function in the proper working of the CRT. After the parts are formed, they are tumbled with hundreds of pounds of pebbles to smooth off the rough edges. Some parts from punch press and some purchased parts go to this area, the machine room. Here we do more work on parts, such as welding. This auto pin welder, just like the name says, welds pins to metal parts automatically. Also, the helix for the subassembly is formed here. And many other parts are welded together. Workers in the machine room also perform quality inspections on metal wafers. Using a microscope, they check the opening, or aperture, in the metal wafers for any burrs left after the punch press operation. The electron beam must pass through this aperture without interference, or the CRT will not function properly. Some of the metal parts go to the welding areas where they are put together into assemblies. One process in this area is called spot welding. This is a batch assembly operation. In other words, one operator does a complete assembly of a group of parts. These operators make hundreds of different sub-assemblies which are stored in covered pans before being used by other departments, like the cathode area. The cathode is the heart of the CRT. This white coating is the beginning of the electron's journey through the tube. The electrons emitted by the cathode will strike the phosphor on the inside of the faceplate and light will be generated. To create a cathode, a hollow metal pin is inserted into a tiny ceramic disc. Many layers of cathode coating, the white slurry in the jar, are sprayed on the tip of the metal pin until just the right thickness is reached. The actual assembly of the cathode calls for a delicate touch. If the cathode parts are damaged in any way, it may change critical spacing, making it an instant reject. When the cathode assemblies are finished, they move on to this area, kit prep. Here they are placed in kits with parts from the welding areas. There are kits stored here for each gun type that Tech makes. When a gun needs to be built, the kit is sent to rotting. CRT processes require quality equipment. Well, we've seen some already, but now we're going to see equipment used to complete the CRT. This is the rotting area. Here the operator places wafers, sub-assemblies, and other small parts into this fixture. The fixture will hold all the parts in the correct location during the actual rotting. Now, the term rotting means organizing all the parts that make the electron beam gun and permanently fixing them in glass rods. Glass rods are heated until softened, then pushed onto the support legs of the parts. When the glass cools, the gun parts are firmly fixed into place. The assembly is referred to as a rodded gun. Earlier we saw a comparator used to inspect raw material. Here the comparator checks the locations of parts that make up the gun. Some guns have a conductive coating called DAG applied to the rods. The coating removes stray charges from the glass rods, so the charges won't interfere with focusing of the electron beam. This is the wiring area. Here wires are welded to various gun parts. The wires, in turn, are used to connect the gun parts to the outside of the tube. Also, the stem, made earlier in glass fabrication, is added. The pins are welded to the wires and cathode. The pins will provide the electrical contact needed to operate the CRT and to adjust the trace. The gun is sent to stem seal, where a section of tubing is melted or sealed to the stem. And most guns return to wiring, where a few more leads and connections are welded onto a band. This band holds pins that lead to the outside of the tube. Some CRTs have a mesh dome. This dome lets us shorten the CRT and still have the same performance. The mesh is very fragile and must be handled with utmost care. The mesh is formed and coated in the mesh fabrication area. Then it's sent to seal and exhaust to be attached to the gun. Remember the bulb we assembled earlier? Well, now it's time to join the bulb to the gun by melting the two pieces of glass together. This sealing technique, like all other processes, requires practice and skill. With the sealing completed, our CRT is almost done. Since any molecules that the electron beam strikes will diffuse it, as much air as possible must be removed from the tube. To do this, we use a machine called the inline pump system. The inline pump draws out most of the air. The vacuum inside the tube now is like the vacuum 100 miles above the surface of the Earth. Next, the stem is heated, making it soft. The vacuum inside the tube and the air pressure outside the tube makes the softened stem collapse, forming an airtight vacuum in the CRT. After a vacuum has been created, the CRT is called a live tube, susceptible to implosion. Here is a test where a live CRT was imploded so our engineers could study the results. An implosion is the opposite of an explosion. Any shock or jar to the tube may break it, causing all the pieces to be pulled inward and then rebound off each other. It looks like an explosion, and with this much glass, it is dangerous. People working with live tubes are trained how to handle them safely. Returning to the process of making a CRT, the tube now goes through several additional processes, such as flashing the getter. That's quite a term, isn't it? Well, the getter, the small disc on the side, is heated, giving off barium. The barium vaporizes, then condenses on the inside of the neck glass. It absorbs gas molecules. The shiny metallized area over the getter is barium. Then on to the activation rack. This is the moment we introduce electricity to the cathode assembly, causing it to heat and give off electrons. Now that the CRT is completely built, let's see how well it works. Here in test, the quality of the component parts and materials and the workmanship that went into their assembly becomes apparent. The finished tube is inspected for defects using an instrument that simulates an oscilloscope. The numerous tests that the CRT is put through will check the alignment of the gun to the bulb, check the alignment of all the parts that make up the gun, and will detect any contamination that interferes with the performance of the CRT. Once the tube has successfully passed this rigorous testing, it goes to shipping, where the faceplate is again scrutinized for scratches and contaminants. Then into the sandblaster to clean the outside of the funnel. Pencil marks, hand oil, and the like could conduct electricity and interfere with the operation of the CRT. Therefore, they must be removed. A conductive coating is applied. The high voltage lead is added. And on some tubes, coils are put into place. They will create a magnetic field inside the tube which rotates the electron beam so that the trace coincides with the graticule lines. Next, the base cap is cemented into place. And the tube is carefully packaged, ready for shipping to the customer. In this case, the customer is the scope assembly area, where the CRT will be put into the oscilloscope chassis. As you can see, every single job along the way must be done exactly right to produce a high-quality CRT. And that's why we started and ended our tour at quality awareness. Each worker has the responsibility to do it right the first time. Quality awareness is a commitment that we must have. By meeting this commitment to quality, every one of us will benefit.